Welcome back. Today we're going to continue to explore what that truck speaker was doing when it was vibrating and making sound. But this time we want to figure out what it was doing when it was making a high-pitched versus a low-pitched sound. So take out your pencil, your journal slip, your science journal, and that speaker simulation link from yesterday. Have you heard that word pitch before? Maybe in reference to singing. Pitch refers to the highness or the lowness of a sound. Like when you hear a deep voice, that's a low pitch. Or you hear an opera singer hit a high note, that high sound is a high pitch. Today we're going to use that simulation to continue to explore sounds, but this time we're going to make the sounds high and low. And that simulation is going to graph how the speaker is vibrating back and forth when it's making a high or a low pitch sound. So get that simulation link ready in a nearby tab so you can navigate with me. I'll give you a chance to do so. All right, I'm headed out to the simulation. I'm going to change this to sine. I'm also going to change this volume just to the middle right here. And the first thing we need to do is figure out which keys make low-pitched versus high-pitched sounds. Go ahead, play around with the white keys and see if you can figure that out. You figured it out? Yes. The keys over here on the left are making a low-pitched sound, and over here on the right, they're making a high-pitched sound. Now, let's see how the speaker is moving when we make a low-pitched sound. We're going to apply a force to key Q. That's going to cause the speaker to move back and forth from rest position, and let's see how it does it. Take a moment to graph this on your journal slip. All right, let's see what happens and how the speaker moves when it makes a high-pitched sound. Graph that on your journal slip. So what did you notice this time? Well, one thing I saw is that the amplitude or the height of the peaks and valleys, they didn't change. The peak came up either this high or the valley came down this low. Well, that makes sense because we never changed the volume. When we pressed Q and P, it was the same level of loudness. All right, so what else? Yes, the number of peaks in this given time frame was different. Look, the low pitch, way fewer peaks or valleys. Many more peaks and valleys here. Okay, I want you to do the next part of the simulation on your own. Continue to explore pitch. Follow the directions on your journal slip. We'll come back in a moment. All right, let's inspect both graphs. I've put them here on the screen for our reference. So here's what's happening during a low-pitched sound. Again, the dashed line is a rest position. And here's what's happening during a high-pitched sound. Did you notice a pattern? Yep, same S shape or wave pattern on the graphs. And you probably saw a repeating pattern, right? The same thing. From one peak to one peak is a wavelength, or from one valley to one valley is a wavelength. Peak to peak, valley to valley is a wavelength. But what was the biggest difference between these graphs? Yeah, it was the number of peaks or valleys in a given time frame. The time frame is shown along the bottom here. And so for a low-pitched sound, we see fewer peaks or valleys. High-pitched sounds have many more peaks or valleys in the same time frame. So what does that mean? What's going on with the vibration? Well, that means that low-pitched sounds, you know what's going on with the speaker? The speaker is vibrating back and forth, but it's doing so less frequently, more slowly. The speed of the vibration is slower, resulting in a low-pitched sound. But here, look, the speaker is vibrating back and forth, back and forth, back and forth, really frequently, really fast. We say that this has a high frequency leading to a high-pitched sound. So Frequency is really the number of peaks or valleys in 1 second, in the time frame of 1 second. And when the low-pitched sound was playing in the simulation, the graph didn't have many peaks and valleys in the time frame. But when it was playing a high-pitched sound, it had way more peaks and valleys. And so what that really means is that the speaker was vibrating slowly here, and the speaker was vibrating back and forth very fast here, more frequently. Low frequency, low-pitched sound. High frequency, high-pitched sound. So in our speaker and window phenomenon, we now know more about how that speaker was behaving when the sound was made. When the truck speaker makes sound, the speaker itself, we know it's moving back and forth. It vibrates. And if it moves back and forth a great distance from rest position, it has a large amplitude. And what do our ears hear? Come on, with a large amplitude, do we hear a loud or soft sound? Yes, we hear a loud sound. Higher amplitudes produce louder sounds. But the speaker not only moves back and forth, it moves back and forth at a certain speed. If the speaker vibrates quickly in a given time frame more frequently, we say it's vibrating at a higher frequency. If that happens, what do our ears hear? Come on, do we hear a high or a low sound? Yes, we hear a high-pitched sound. High frequencies make high-pitched sounds. So anything that makes sound is vibrating. That sound could be loud or soft, depending on how far it moves from the rest position, and the sound could be high or low-pitched, depending on how fast it vibrates. All right, let's wrap this up with a few exit tickets. It'll really help bring everything together and check your understanding. Here we go. How does the truck speaker make a loud sound? Yes, the speaker has to move back and forth pretty far from the rest position, as you can see from the high amplitude. Okay, so then how does the speaker make a soft sound? Absolutely correct. The speaker moves back and forth a small distance from its rest position, as you can see from the smaller amplitude. Now, how does the truck speaker make a low-pitched sound? Yeah, you're on a roll. It moves back and forth slowly. So on the graph, I don't really see many peaks and valleys. I see a low frequency. And then how does the speaker make a high-pitched sound? You got it. The speakers move back and forth quickly in a given time frame. So we see a lot of back and forth movement in this given time frame, a high frequency. Today, submit your journal slip, high versus low pitch sounds, and then take another Google form to check your understanding. Until tomorrow, keep thinking and keep learning.